Okay, move to the last question of this question paper. The planet Captain B orbits Captain stars. Scientists think the conditions on Captain B could enable the long-term survival of humans. The spectrum of radiation emitted by Captain star has a peak of intensity at wavelength lambda max of 8.12 × 10⁻⁻7 meter. Show that the surface temperature of Captain star is about 3600. So which formula we will be using for this? Which formula we will be employing for this? We will say that lambda times T is a Wien's constant. Lambda times T is equal to a constant, that is Wien's constant. So lambda is lambda max. So lambda max into T is a constant. So from this you can calculate the temperature. What is that constant? You can refer the data sheet to get that Wien's constant. What is that value? Wien's constant 2.898 into 10 to the power of -3. So you can plug that value. So 2.898 into 10 to the power of -3 divided by lambda max 8.12 into 10 raised to -7. So we will get 3569 Kelvin. So it's nearly 3600 Kelvin. So here make sure you should always remember T is in Kelvin. Now, second question. The distance from Captain star to the planet Captain B is 2.55 when raised to 10 meter. The intensity of light received on the Earth from the Sun is 1380. Show that intensity of radiation received at Captain B from Captain star is about 0.4 IE. Radius of Captain star is 2.03 and raised to 8 meter. So what is the equation connecting intensity and the luminosity? Intensity is luminosity by 4 pi d square. And what is the equation for luminosity? Luminosity means that is sigma a t raised to 4. Luminosity is sigma a t raised to 4. Sigma is a constant. A is the area. So what is the area of area? Area is 4 pi r square, surface area of the star or planet. Now, refer the Stephen's law and you can just take sigma value and you can first calculate the luminosity. So what is the value of the luminosity of this? That is Stephen's constant is sigma is 5.67 multiplied by 10 to the power of -8. What is the area? 4 pi into radius. So what is the radius of Captain star? That is 2.03 into 10 raised to 8, 4 pi r square. Into what is the temperature? What is the temperature? So temperature is, you already got that temperature, right? Because it's actually given in our question. I mean, it's an introduction part. So what is the answer? You can take whatever be the temperature you are getting, 3569 to the power of 4. So the luminosity, we will get it as 4.76 multiplied by 10 to the power of 24. Now, what is the intensity received on Earth from the Sun? Is 1380. Show that intensity of radiation received at Captain B from Captain Star is 0.4 IE. So please calculate the intensity in this case. The luminosity, that is 4.76 into 10 to the power of 24 divided by 4 pi multiplied by, then what is the value of R? What is the value of R? R is the distance from Captain Star to the planet Captain B. That is 2.55 into 10 raised to 10 whole square. So that is nearly 583 watts per meter square. What is the intensity received on Earth's surface? That is 1380. We need to compare it, right? So what is this intensity? We can say it is 583 the intensity ratio. 583 divided by 1380. What is that value? 583 into 1380 into 1. We can just rearrange this. 583 divided by 1380 is nearly 0.422. Then this is intensity on the Earth. Hence, we can say that it is nearly 0.44 or 0.4 IE. Hence, we short. Hope you got that idea. Because this is our star. This is the planet. So here we need to, if you want to find the intensity, this is the surface area. 4 pi r square is the surface area. So intensity is whatever be the luminosity divided by 4 pi r square. Okay, the last part of this. Humans would not be able to survive on a planet with a gravitational field strength 4 times greater than the gravitational field strength at the surface of the Earth. Deduce whether humans could survive the gravitational field strength at the surface of Captain. How will you do this? Radius and the density is given. Basically, the equation for G is G into mass of that planet divided by mass of the planet divided by the radius of that planet square. G is, we know that 6.67 into 10 raised to minus 11, that is a universal constant. Mass of the planet is unknown, and the radius of this is 1.02 into 10 to the power of 7. Now, how will you find the mass of the planet? Mass of the planet divided by volume of the planet is density. So the mass of the planet is density times volume of the planet. Density is 6.44 into 10 raised to 3, and this is volume of this is, how will you find the volume? Because the radius is given. So 4 by 3 into pi into radius is 1.02 into 10 to the power of 7 pi r, 4 by 3 into pi r cube into 10 to the power of 7 whole to the power of 3. So if you are substituting this, we will get the mass as 2.86 into 10 to the power of 25 kilogram. Substitute this value, 6.67 and raised to minus 11 into 2.86 into 10 raised to 25 divided by 1.02 into 10 to the power of 7 whole square. and we will get it as 18.4 Newton per kilogram. Now, we need to find the ratio. The ratio of acceleration due to gravity. This is acceleration due to gravity at the planet. So acceleration due to gravity at the planet divided by acceleration due to Earth. So that is 18.4. Acceleration due to gravity or gravitational field strength on the surface of the Earth is 9.81. So if we are dividing, we are only getting 1.87. So what is the conclusion? Which is, because they are saying that humans will not be able to survive if this is 4 times greater. This is only 1.87 times. So which is less than 4. So humans could survive the gravitational field strength. Could survive gravitational field strength. So that is the idea about this question. And that's the end of this paper. Thank you very much.